You know that dream we've all had about having a robot helper around the house? One that can do pretty much anything you ask it to? Well, for decades, that's been the goal. But it turns out there's this one really stubborn problem that's been holding that future back.
And this is the big question, isn't it? It sounds so simple, but for an AI, this is a massive, massive hurdle. See, every time we try to make a robot really good at one specific physical thing, we accidentally make it, well, dumber at everything else.
So here's what we're going to dig into. First, we'll unpack what's called the smart robot paradox. Then we'll look at a really cool solution that's actually inspired by our own brains. After that, we'll check out the tech that makes it all work, and finally, see the results for ourselves. Ready? Let's dive in.
Okay, first things first, let's get right to the heart of this problem. There's this fundamental tug-of-war going on inside the AI brains that power these advanced robots.
So, the AIs we're talking about are called Vision Language Action Models, or VLAs for short, and they are incredibly powerful. They get their start by basically absorbing a huge chunk of the internet, text and images, which gives them this really amazing general understanding of the world. And this is where you can see the conflict in action. On one side, the robot needs all that general knowledge just to understand a simple command like what a coffee mug even is. But on the other side, it needs to be fine-tuned with very specific data to learn the exact physical movements to, say, place that mug on the coaster.
And here's the kicker. That fine-tuning process leads to a huge problem with a pretty dramatic name, catastrophic forgetting. Basically, as the AI learns that new physical skill, it starts rewriting its own programming, and in the process, it just erases its original knowledge. The researchers put it perfectly. The model essentially sacrifices its linguistic brain to gain a robotic body.
So what do you do about that? How do you solve it? Well, to figure out this digital problem, researchers look to the best computer we know of, the human brain.
And the answer, it turns out, is right there inside our own heads. They took inspiration from this principle called hemispheric lateralization. It's just a fancy way of saying that the two halves of our brain are specialized. They have different jobs, and they don't try to do everything at once. This breaks it down perfectly. Think of it like this. Your left brain is the what department. It handles the big picture stuff, like language and understanding concepts. And your right brain? That's the how department. It's the specialist that handles spatial awareness and the fine motor skills needed to actually do things. They work together, but they stay in their own lanes.
And that leads to this really brilliant idea. What if we could actually build a robot's AI to copy that same elegant design? What if you could separate what it knows from what it does, so they can't overwrite each other?
And that is exactly what these researchers did. They built a brand new architecture called TwinBrainVLA, and as you can probably guess, it's designed to work just like our own two brain hemispheres.
Okay, so let's walk through how this thing actually works. First up, you have the left brain. This is an AI model that's been pre-trained with all that internet knowledge, but then it's frozen. It's locked down so it can't be changed. Then you have the right brain. This one is totally trainable, but it's only focused on learning physical robot skills. Now, to make them talk, there's a special one-way bridge that lets the right brain ask the left brain for information, but it can never, ever change it. And finally, an action expert takes all that combined info and turns it into precise movements for the robot. So this is the whole idea in a nutshell. The left brain is like this stable, unchanging library of knowledge. It's the anchor. Meanwhile, the right brain is flexible. It's always learning, always adapting to new physical challenges, but without any risk of causing that catastrophic forgetting. It's brilliant. All right, so the theory is super elegant, but here's the million-dollar question. Does it actually work? Well, the researchers put the TwinBrainVLA through its paces with some really tough tests to find out. They use this really challenging simulation called Robotics, and it's not just simple stuff. It involves 24 different complex household chores. We're talking about things like opening a cabinet, picking up a bottle, putting it inside, and then closing the cabinet door. Tasks that need both deep understanding and super precise control. And the results, well, they pretty much speak for themselves. When they put TwinBrainVLA head-to-head against another top-of-the-line single-brain model, the two-brain version had a way higher success rate. We're talking almost 55% success, compared to just under 48% for the old model. Now, I know a 7% jump might not sound like a crazy number, but trust me, in the world of robotics, an improvement like that is a huge leap forward. Just by splitting the AI's brain in two, the robot became way more reliable and way more effective.
And this really gets back to the core of the breakthrough. The researchers themselves say that this new design structurally immunizes the model against that knowledge loss we talked about. It's not just a slightly better way to train an AI, it's a fundamentally safer and smarter design. This really feels like it's opening up a whole new chapter for robotics. Instead of having to choose between a robot that knows a lot or a robot that can do a lot, we can finally have one that does both. It's a massive step toward those truly helpful robots we've always wanted. So I'll just leave you with this thought. If you had a robot that could keep learning forever without forgetting, what's the very first thing you'd want it to solve?